Okay, so lesson 3, square roots. So we're dealing with square roots here. Now a root can also be called, dun 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 dun, a radical. So when we have our square root, we have this, I will call it a lot, I'll call it your square root bracket. And that's so you know what I'm talking about. So that's this part. Underneath the square root bracket, we have what we call the radicand. Okay, so that's the number we're taking the square root of. Now, basically, with the square root, what it means is that anything under there, we want to know what times itself will give you that number. Okay, and it's the opposite. Remember when we're doing exponents, it's the opposite of a square. So, you know, if we have an x squared, the opposite of an x squared is a square root. Okay, now we want to talk a little bit about perfect squares. Perfect squares is a number that is a square, power of 2, of an integer. For example, 9 is a perfect square because 3 squared is equal to 3 times 3, which equals to 9. Now, the neat thing with square roots is that means that square root of 9, if we have 9 as the radical, will be, it's the square root of 3 times 3. So we've said what number times itself will give you 9, so the square root of 9 is equal to 3. Now, what are some square roots that you have memorized? You might have some memorized. The square root of 4 is equal to 2. We've just done the square root of 9. It equals 3. Square root of 25. Well, that's 5 times 5. So it equals to 5. Okay, those are some examples. You might also have 16 in there. We usually know a lot of the small ones. Now, squaring and taking a root are inverse processes. I've kind of talked about that a bit. Inverse means they're kind of the opposite. So for example, 5 squared equals 25. So the square root of 25 is 5 times 5. So the square root of 25 would equal 5. Okay, so there's a relationship there. So this next section, practice, we're looking for exact square roots. Exact means no decimal. Okay, if possible. So square root of 49, well, that's the square root of 7 times 7, so it would be 7. Okay, square root of negative square root of 64, well, 64 is 8 times 8, so this would be equal to negative 8. Now, important to note, this negative sign is outside, right? So it is not affected by that square root at all. Now, if you have a negative sign, however, underneath the radical, there is no answer. It's not possible because think about our integer rules. There's no, you can't multiply a negative times a negative and get a negative. There's no way you can get that, right? There's no way you can't take the square root of a negative number, okay? So remember that, okay? So that's a very important piece of information. No solution, okay? Now, we have some trickier ones here. When we have something like so, this is the same as the square root of 16 over the square root of 25. Now that's going to be the square root of 4 times 4 over the square root of 5 times 5. So I can take the square root of 4 times 4, or 16, and it's 4. And I can take the square root of 5 times 5, or 25, and it is equal to 5. Okay? Similarly, if I have something like this, this is the same as the square root of 12 over the square root of 3. Now, I can also reduce these. I'm going to actually reverse. Oops, I did the wrong thing with my pen. I want an eraser. Okay, this is what I want. For some reason, it's giving me, there we go. My pen went on a little rampage there. So I can actually divide those first. They're inside the bracket. So let's simplify that. What is 12 divided by 3? Well, 12 divided by 3 is 4. 4 is equal to 2 times 2. So the square root of 4 equals 2. Okay? Now I can do the same thing here. I can reduce this fraction. So I have this fraction underneath. And what can I divide out of both 5 and 45? Well, I can divide out a 5. So this will be 1 over 9. Now, this is the same as having square root of 1 over square root of 9. So square root of 1 is 1. Square root of 9 is 3. Okay, so always look for a way, can I simplify it first before I start doing this evaluation? Okay, square root of 0 is 0. 0 times 0 equals 0, right? So that's what we would get there. Square root of 7. Now there's no two numbers that give us 7, okay? So no exact root, okay? You could get a decimal number if you use your calculator. So it would equal something around 2.645 ... But it is not an exact root, and this has asked you for exact roots. Okay, it's not a perfect square. Not a perfect square. Okay, alrighty. Square root of 5 squared. Well, that's the same as 5 times 5, which we could write as 25. So that would be 5 as my perfect square. And I don't like the way that 5 looks, so I'm going to rewrite it because I roll that way. Okay. Negative 15 squared. Well, this would be equal to negative 15 times 15. I have them squared under there. It's an inverse. Now, I can expand it out if I want, which would be 225, but I'm still going to get negative 15. Now, note, this negative sign hangs around because it's outside the bracket, okay? If it were under the bracket, there would be no solution, so please be aware of that. Okay, 0.64. Now, again, it's a decimal, so it's not a perfect square. If I use my calculator button and find the square root, it will be, equal to 0.8. So try that, and you should get that for it, but it is not a perfect square, so be aware of that, okay? Because we want a non-decimal answer. Now here, it's an addition question. So what I have to do is I have to find the solutions to each of them and then add. So the square root of 16, well, 16 is 4 times 4. So the square root of 16 is 4. And the square root of 25, 25 is 5 times 5. So that's 5. And then I would add them and get 9. Okay, simple as that. Alrighty. Now you can also use your calculator, and if we are, notice here it says to the nearest tenth, so we're not looking for perfects necessarily, not perfect squares. Okay, and that's fine. So if I do root 3, I use my calculator. So I hit 3 and I hit that. There should be a button on your calculator that looks like this. And there might be an X there. okay? If you have a graphing calculator, just ask me and we can take a look at it. So square root of 3 is 1.7, and it says to the nearest tenth, right? Square root of 17, put 17, hit that button, I'll get 4.1. Square root of 41, punch it in my calculator, I'll get 6.4. And then here, my negative sign's outside the bracket, so I can keep that, and I'll get negative 9.7. That's really using your calculator to calculate it, okay? Now, we can also estimate square roots if we think about the numbers on either side, okay? So, estimating the following roots. How would we do that? Well, I would think about the two square roots on either side. So I have negative 9 here, and it is less than negative 10, or I don't have negative 9. I have root 9 there, which would be less than root 10, which would be less than, well, the next perfect square would be 16, right? So for each of these, square root of 9 is 3, and the square root of 16 is 4. So estimating, I know that the square root of 10 is going to be somewhere in between there. So I think it's going to be closer to the 9 than the 16. So I'm going to estimate it as being approximately 3.2. I can check that with my calculator. So if we do the square root of 10 on our calculator, we'll get 3.16. But we're just estimating, so we can leave it like that, okay? So, and we can also take a look at our number line. So we would put it somewhere in here, right? Now for 110, again, I'm going to think about my roots on either, perfect squares on either side. On one side, I would have 100. It's less than square root of 110, which would be, and the next greater one would be, well, 10, this is 10 times 10, right? So this is 10. So the next one would be 11, which would be 120. Oops, I'm going to do it in the right color here. Sorry. I'm going to keep it in red. 121, right? Which would be, the square root would be 11. So that means it's going to be somewhere between them. It's about halfway. So I'm going to think that the square root's going to be approximately halfway. So somewhere between 10 and 11, I'm going to say it's around 10.5. Okay, so if we put that on our number line, it'd be around there. And we can check that. 110, hit the square root. It's 10.48, so 10.5, okay? So basically we're looking at the two roots on either side, right? So let's look at this next one, root 5. Well, root 4 would be, that's the number just below it, and it would be less than root 5. And then the next one up, well, root 4 is 2 squared, so 3 squared would be root 9. Now 5 certainly is a lot closer to 4 than it is to 9, but this would be 2 root 5, and this would be 3. So I think it's going to be closer to the 5, so I would say it's approximately, we could say 2.2, okay? So if we take 5 and take the square root, yeah, I get 2.2, so I'm in the right ballpark, okay? So, and you know that this symbol here means approximately, right? This is means approximately, okay? Okay, and one last one. So we're really looking at either side, right? So the square root that is just lower than square root 70 would be 64. So that would be 8. Now, the next one up then would be, well, 9 squared, which would be 81. Okay, so I know that 70, the square root of 70 is going to be somewhere between 8 and 9. Now, 70 is closer to 64 than it is to 81, but not by much. So I'm going to say approximately 8.4. It might be closer the other way. We can check. So I get 8.36, so I'm in the ballpark, okay? Again, it's an approximation. So we can think about this on a number line, how that exactly fits. So we know it's somewhere in between here would be root 70, and we know down here somewhere in between 2 and 3, around 2.2 would be root 5, okay? Just kind of thinking where they fit in comparison to other ones, okay? So let's look at some more examples. So that's estimating, really kind of looking at the ballpark. If you want to take a screenshot or if you want to pause here just to write that down, you can do that now. Press pause. Okay, so let's do some more examples of simplification. And I think the big thing is that just like with BEDMAS, we do exponents first. With BEDMAS, we're going to treat the square root bracket almost like it is a bracket, okay? So when we say BEDMAS, we'll do those first. So here, we'll solve what we can. Square root of 9 is 3. Square root of 16 is 4. So our answer would be 7, okay? Next one, however, they're both underneath the square root, so you would almost treat them like they are a bracket, and you would solve first. You would do the addition, okay? So 9 plus 16 is 25. Square root of 25 is 5. So if we compare those two, there is a difference between doing it under the bracket first or out of the bracket, okay? Next one, we have negative square root of 16 is 4 minus negative square root of 4 is 2. So remember, I like to go plus a negative, so I would have negative 6, okay? So be careful about that. Here, negative square root of 64 is 16 minus 16. Change this to plus a negative, so I would get negative 32, okay? So just watch where your negative signs are and how you're dealing with them, okay? 2 root 16. So here, do the radical first. So 2 times square root of 16 is 4. So 2 times 4 is 8. So we treat this like it's in brackets. 25 times 4, or root 4, again, treat it like it's in brackets. So 25 times 2, so we'll get 50, okay? So you can see how you kind of have to solve these. Treat these like they're in brackets, okay? And you're gonna solve them first. So negative 5 times 2, because square root of 4 is 2, plus 10 times 3. So this will be negative 10 plus 30. Negative 10 plus 30 is 20, okay? And then there's no question there. Now, we also use the Pythagorean Theorem a lot when we're doing, when we're talking about square roots because of the nature of the formula. So let's just talk about the Pythagorean Theorem, okay? Pythagorean Theorem says if we have a triangle, dun, 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 so, like so, A, B, C. Now, it doesn't matter much which is A and which is B, but C has to be the hypotenuse. The hypotenuse is always the longest side across from the right angle, okay? Okay, so we use this formula, A squared plus B squared equals C squared. And we have to do some rearranging. So in this first one, C has been identified. We can make this side A and this side B. Again, it doesn't matter which is which for A and B. So taking our formula, a squared plus b squared equals c squared. You'll notice I like to write my formulas out first, and then we're going to substitute. So a squared is 6 squared, and I don't know why I wrote 6 to the power 6. That was just a weird thing. And 8 squared for b squared is equal to c squared. We're going to add these together. 6 squared is 36 plus 8 squared, which is 64, equals c squared. 36 plus 64 is 100. So at this stage, if I want to find c, I have to take the square root of both sides. So c would be equal to 10. Okay, now when that works out, that we have all perfect whole numbers, we call this a square triangle. Okay, it's a special triangle. All right, now here we have roots. Oh no, miss, what happens? Well, first let's label. We know our side A is what we're looking for. We'll call this one B, and this is the hypotenuse, right? So it is C. So let's write our formula out. A squared plus b squared equals c squared. Okay, now let's fill in. A squared is a squared. We're looking for it. B squared is root 2 squared. And c squared is root 3 squared. Now here's what happens. When I take a square root and I square it, I am going to actually get the number underneath. Okay, so I would actually get, it would be like going root 2 times root 2, and this would be like root 3 times root 3. So this would be root 2 times root 2 is root 4, and root 3 times root 3 is root 9, right? Now, I didn't have to do all this. I can just look at the fact that this is squared and it's under a root, and I can skip to the next step. This is plus 2, and this is 3, right? Because the square root of 4 is 2, the square root of 9 is 3. Now I want to move this 2 over. So what I'm going to do is I'm going to subtract 2 from both sides. When I do it on this side, I get 0. So I get a squared is equal to 3 minus 2, which is 1. And then I take the square root of both sides. So a will equal 1. Square root of 1 is 1. Okay? Now again, these steps here, I just wrote them out so you knew what was happening mathematically. You should be able to make the jump from the second step to the fourth step, or fifth step, okay? If you can't, write it out, it helps, and then away you go. So this is our work with exponents, or square roots, sorry, we've done exponents, so you've got some practice to do, and there's some other worksheets for you to